we are going to be discuss is the continuation of yesterday live, guys, because yesterday the complete project what we plan to do is, yeah, so the project which are going to be we have been planned is, so we are going to be taking the two peripheral. One is we are going to be taking an ADC. Okay, so because we need to be understand about the concept of ADC. At the same time, we need to be understand about the protocols and all. Okay, so for that, we have been taken one microcontroller. This is STM32 microcontroller, and this one is Arduino. Okay, and this another receiver, and we are going to be collecting the data. So this is a pot meter. We are not collecting any sensor data. We are not collecting anything else. We simply getting the voltage. We are just reading the voltage only, because the ADC module. We are just taking ADC module of pot meter. So this pot meter is like a resistance, adjustable resistance value. It is contain the 3 pin. One is power pin 5 volt. So it is connected with the 5 volt of STM32, and another one is a ground pin which is 0 volt. So we always know that. So whenever is zero ground and high power going to be created, this is the potential difference between two, and the current will be flows. Now we are only reading the voltage value. This voltage value which is in the form of analog. So for that we are using a ADC converter which helps to convert this analog of 0 to 5 volt completely to the digital value. Okay, so how we are going to be find it out, which is consider the digital value. So we have to be read the data sheet. Okay, so here you just simply open up the data sheet, and what the microcontroller you are exactly using. Okay, first of all, you're going to be check what microcontroller you are exactly using. Based on the microcontroller, you're going to be read the thing, how many ADC it is having. It is only one ADC of 12-bit ADC. So if it is a 12-bit ADC, your data going to be read from 2 to the power of 12. So which in a sense 4096. So the analog of 0 to 5 volt gonna be read in digital form of 0 to 4095. Okay, it is going to be get mapped. So if you are studying in the Arduino, we have to map the thing. So the analog and you just simply put like 5 volt, 0 to 5 volt going to be mapped the 0 to 4095. Based on that, for example, 0.1 volt means it will be get some value like 100. Okay, for example, 0.7 volt means it just simply consider 800, like that one. It is going to be get mapped. Okay, so this is the what. Okay, so we have to be converting the analog to digital data. After when you're going to be converted that digital data you're going to be send this STM32 microcontroller to Arduino microcontroller. For to transmit the data, we are introducing one protocol. We already studied this protocol called as an UART protocol. With the help of this UART protocol, we are just transmit the data. Okay, so it is having a TX and it is having a RX. So through this transmitter pin, we just transmit the data, and Arduino, which is actually receiving the data of. So whatever the changes we actually doing. So 0 to 4095 we are doing. So that 0 to 4095 going to be received on this Arduino, and we can able to read it over there. So this is the actual project we have been planned to do. Okay, yesterday the first phase of this analog to digital conversion, because with help of the STM32 F411RE microcontroller, we just simply doing the analog to digital conversion. Your analog data of 0 to 5 volt, which is read through this STM32 microcontroller, 0 to another one is 5 volt. So with the help of this analog pin, it just considering the pot whenever you just manipulating the pot meter, depends on that it is going to be varying. So this ADC converter, which helps to convert the 0 to 5 volt between that value in the form of digital data. That final digital data going to be sent on the Arduino. Yesterday, the first phase of analog to digital conversion has been completed. So we have been completed the analog to digital conversion. So today we are going to be concentrate on the final conversion data going to be sent to the Arduino. So for that we are going to be study about the UART protocol. Okay. So here if you just see this one, yesterday what are the things which have been completed? So this complete thing has been completed. Okay. So I'm just simply put one so what are the things which we had been completed? I'm just simply put command, okay, and based on that, it is easy to be learned. Okay, so what are the things which we had left over, and we will start to be continued. So these are the things. What are the register which is required to be manipulating the ADC? So we have been initialized the ADC, and finally we just use that ADC to start the communication and get the data. So these are the stuffs we have been already completed. And today we are going to be study about the UART. Okay, so you have to be understand another thing in STM32 F411RE microcontroller. It is having a UART protocol. What it is actually having, it is having a UART protocol. Okay, so this UART protocol is having some difference. Okay. So the difference between this UART and UART is you have the difference of it is going to be using a clock, and it is going to be use clock plus baud rate, and it is going to be use only the baud rate part to transmitting the data. The main differences. Okay. So yes, can you able to give the acknowledgement, guys, whether my audio is clear or not? Okay, if you got clear up to this point, you just post clear message on the chat box. Okay, so the very important parameter is, guys, so this is what the thing. So STM32 is just having a user. Okay, yes, all the people have been posted got clear and is clear. So Jagan, you just click the audible button to be enable the voice. Okay. Might be, yeah, yeah. So while you're going to be enter into this live, guys, you should be enable the audio button. Then only you can able to hear my voice. Okay. So now we will concentrate for to be configuring the user. Okay. So if it is come and go, it might be the network issue also, guys. So sometimes if it is a network issue happening on your side, so the voice might be in trouble. Okay, so you just reload it or choose any other location. uh, so and now we will concentrate on UART, guys. Okay, so for to be concentrating on UART, first of all, I'm just open up my data sheet of page number 15. Okay, here you can able to see this when. Thank you, Thirmal. So thank you so much. And if you just see this one, guys, you can able to clearly see this. What you can able to see, which UART you are going to be used. Okay, because we are having the multiple UART is present over there. Okay. Yes, I can understand, Thermal. Yes. So the thing it is, guys, we are going to be have the different UARTs are there. Okay. So you can able to see this one. How many number of UART we are using? So first of all, if you just having any microcontroller, okay, if you're just having any microcontroller, so I already yesterday explained you this. So you will have the different peripheral like timer, UART, ADC, DAC, memory, processor. So it all contains one microcontroller. Okay. So the what are the things which is present inside the microcontroller? They have been given as a block diagram. Okay. So in this scenario, yesterday we used this ADC one to be configure all the things which you have been studied yesterday. Same thing. Today we are going to be use UART. Okay. So this user 2, we are not going to be choose here. So why I'm going to be tell this user 2, they are not going to be chooses because if you just see STM32 normal on microcontroller, okay. So what you are going to be call it as, guys? So in this image, this USB pin, okay, this USB port is there, okay. This is having a USB port, okay. So this USB port, we call it as an, this is also one of the UART only because it is a serial communication. So it is also having kind of a user. So this port A2 is also present in this place. Okay. So you can also configure port A2 and 3. So transmit and receiving the data of port A2 can also configuring here. Okay, so that is the thing. So while I'm going to be use this port A2, so where did you telling it is present in this places? It is in the user manual. Okay, in this user manual they have been mentioned. So user 2 is taking the uh, USB pin. Okay, so while you're going to be study this user manual, they had been mentioned this detail. Okay, so your USB, which is so all the details we can able to get through this user manual. So what are the pins are there, and what how many connectors are there. So what is the purpose of bootloaders and everything you can able to get it from here. Okay, so this is called as a mini USB pin. So through that only you're going to be connected. After you have been connected, it is connected with the ST link. And it just go to the serial via debugger and the microcontroller. After only it just go to the microcontroller chip. Okay, this is how it is actually connected. So you can completely understand about the microcontroller through this one. Okay, so that is very, very important parameter. Okay, so you can able to get the complete things on here. Okay, so in this one, they have been given about the USB, which is having a port A2 and port A3. So I'm going to be show on this next live session. Okay, I've been studied on this page. Okay, guys, so if it is possible, I'm going to be bring that one on next live session. Okay, so here we are just using this one. Okay, so now you have to be understand. So that's what I'm not choosing this port A of USART2. I'm not going to be use this USART2, and instead of that, I can use USART1 or USART6. You can use any of this one. Okay, so based on your application, so you can use any of this USART. Okay, so that all your purpose. So we are going to be use any of this USART on this one. Okay, so which USART we are going to be used is here you have been using the USART one. So you can also use this USART6 at all. Okay, so first of all, you're going to be initialize the things. Okay, first of all, I'm just going to be start the I'm going to be create one function. Here I'm going to be created one function. Okay, function caller function declaration. Why I'm going to be using this declaration is, so I'm going to be specify, I'm going to be initializing all the parameter, the like bus. I'm going to be set the bit, all the thing I'm going to be do it separately. The continuously happening functionality I'm going to be written inside this while one condition. Okay, so while one, so you can easily understand. I'm going to be teach everything by step procedure. Okay, so you don't consider about this ADC because yesterday we have been completed. Okay, so now we will study this USART1. So if I want to be configure this USART1, first of all, I need to be find out which bus it has been connected with this. So it is connected with this port ABP2 bus. Okay, it is connected with ABP2 bus. USART1 has been connected. At the same time, you have to be find it out this USART1 which is connected with which GPIO pin. So even though you are having the multiple peripherals, even though you are just having a multiple peripherals inside this microcontroller chip, every modules has been connected with any of your GPIO pins. So through that only you can able to interface with any other sensor or any other microcontroller. So it is very, very important thing. So you need to be find GPIO pin. Okay, so how can I able to find it out the GPIO pin? You just come to this data sheet. Okay, in this data sheet, you just simply go to this pin outs, and here it is pin definitions over there. And here you have to be find it out UART1. You start to be search for UART1. UART2 is there. UART6 is there. Here the UART1 is there. Okay. So if you just see this one, guys, so UART1 of transmitter. So in this live, we are going to be only going to be transmit the data from STM32 microcontroller to Arduino microcontroller. For this, I can only use the TX pin on STM32, RX pin on Arduino. Okay, so for that, I'm going to be only choose this transmitter pin. If you are going to be receive the data from any other microcontroller, for example, Arduino, you definitely configure RX also, which is present in this next. So you can able to see that UART RX. UART1 RX. Okay, so in this video, in this today's live session, we are just only transmit the data through a transmitter. So that's what we just configuring the TX. So it is connected with the pin of port A of 9. Okay, which pin it has been connected? It has been connected with the pin of port A of 9. So I've been find it out. I just simply go to that location of block diagram. So I've been find it out. It is connected with the port A of 9th pin. So I've been find it out. This is the GPIO pin. You are also going to be find it out which bus it has been connected. You're going to be imagine it, guys, because this is the embedded system. So in this embedded system, it is having a hardware. Inside this hardware, you are having a GPIO pin. Okay, GPIO pin. GPIO A 9th pin is present. Okay, and inside this one module, it is called as an UART. Okay, and likewise, you are having another timer. Okay, so everything's all there. In this scenario, every pin and port has been connected through bus. Okay, it has been connected completely. It has in the connection of bus. Okay, so each bus which is having a different name. Okay, so like uh, this bus concept is common for all microcontrollers. If you go to this 805 and if you go to commonly, we are going to be using AMBA, that is the advanced microcontroller bus. So in that, it is going to be different. It is going to be separate called as an AHP bus, advanced I bus, advanced peripheral bus. It is common for all. Okay, so most probably all the modules, peripherals, and all is has been connected these two buses, advanced I or advanced peripheral. Now just tell me if you want to be enable this UART, if you want to be enable this GPIO 9, definitely through this bus. Okay, you are just writing a code. You are going to be write the code in any Kale, any STM32 or any other thing, you can able to write it. So while you're going to be toggle one bit, so that toggling the bit, it is going to be, you're going to be uploaded the code for to your microcontroller. Right, you're going to be upload the code into your microcontroller. It is going to be dumped into the chip. So while you're going to be dumped into the chip, you're going to be specifically write the register name. So this is the register I'm going to be use, because everything which is having address, if you are taking a UART having some specific address. Okay, if you're enabling that address, so in that specific address, which bit you're going to be enabled, if you're toggling one, that bit is going to be toggled. So that bit is going to be toggled, so your user has been on. Okay, so if you're just toggling the GPIO A, like through that bus, it's just giving one clock pulse, it is going to be on. So when it is on, okay, your microcontroller is now ready to be doing some function. So this is how it is actually going to be happen. So in this same work, I'm going to be enable my GPIO A and UART1. Okay, so for that, how can I able to do this? I can able to give clock through AHP bus and ABP2 bus. If I want to do this, I need to use the reference manual for to be writing the code. So I just go to this reference manual. I'm just finding the RCC register because all the because bus means through that it is going to be enabling and disabling the peripherals. It is in the form of reset and clock control register. You can able to reset at the same time you can able to give the clock. So I'm just simply search for AHB1 bus. AHB1 ENR bus. In this AHB1 ENR bus, you can able to see the GPIOA. Yes, you can able to see the GPIOA. In this GPIOA, you are going to be enable it as 1. So because they have been given, if you want to be give the clock, you are going to be give 1 to be enable this bit. I need to be enable it as 1. Okay. At the same time, I'm just duplicate this one. I need to be use the second thing that is called as an ABP2. So through this ABP2, I need to be enable the UART2. Yes, here the ABP2. Through that, I can able to enable the UART2. This is the position. I need to be enabled as 1. You just cross verify whether it asking to be enabled as 1. Yes. So 1 means you can give the clock going to be enabled. Okay. This thing you're going to be implemented in your microcontroller. Okay, how can I able to enable it as? So this STM32 is one of the IDE guys. You can able to get all the registers which is present in your microcontroller. They have been given over there. Okay, you don't need to be go for this. All the SFR special function register which is present in your microcontroller chip, all has been presented. Okay, if you just go to the KEL and all, there is no registers has been presented. Okay, here it is, all the registers has been there. Okay. You just simply find it out, go to the RCC register. And in this RCC register, you are going to be finding out the AHB1 ENR bus. This is the address of this AHB. Here I have been not declared because your ADC1, okay, your ADC1 is also have the as also yesterday we studied it, right? So ADC1 is also connected in this port A of 1. So for that, I just commonly declared, so AHB1 ENR is having this address. So I just commonly use it for the ADC and user purpose. Okay. At the same thing, if you just check it here, your UART1 and ADC1 is connected on the same bus. Here we are not going to be completely setting what functionality it is going to be. It is, we are just simply enabling the stuff like I'm going to be enabling the ADC one, I'm going to be enabling the user, just giving the clock pulse. Okay. So I'm not going to be do any functionality over there. So simply I'm just giving one clock. Okay. So if I can already given to this one. Okay. I just simply given the clock through this one. But here only one thing is going to be changed. So what the thing is actually going to be changed? Your port is going to be changed. Because if you just see this one, yesterday we have been used the GPIOA, so that is going to be same. Okay, here I didn't mention any GPIOA and all. Okay, yes. So here the address only going to be get same. So yes, here you just come to this user one, you can able to see the same thing as being presented. Here I just given the name called as ADC initialization. Here I just given the name called as a UART1 initialization because both are GPIO has been connected. But it is port A of 1, it is port A of 9th pin. Okay, both going to be get vary. And second thing, you are going to be enable the peripheral called as an ADC1. Yesterday, we enabled the peripheral called as an ADC1. Today, we are going to be enabling the UART1. So if you want to be enable the UART1, it is presented at the location of 4. ADC presented at the location of 8. It has been done. It is 4. So I'm going to be shift my bit. Okay, I'm going to be set 1. So at the 4 times, I'm going to be shift. So after that, I just set the bit of UART1. Okay, it has also been completed. Okay, so after what you're going to be do it, guys. So after you're going to be set this ADC1 UART and all. So we have to consider UART only right now. Okay, you have to go to the MODA register. Okay, so this motor register is for the GPIO register functionality. Okay, so you just simply enabled give the clock and you just simply enable the stuff. But you are going to be study what the functionality is actually going to be do, whether it is act as an input or output or alternative or analog function. Okay, so which mode it is actually going to be performed. So ADC, we know it is analog. Okay, so it is a UART which comes under the alternative function. Why? Because it is going to do the multiple function like TX as well as RX. So both thing is possible. You can also transmit, also receive the data. Whenever you will get the multi-functionality or alternative functionality, because one is transmitting, another one is receiving. Both are alternative one. Okay, even though you're not using receiving functionality, you're just configuring it as an alternative one. So I'm just configure it as an alternative function. Okay, before that, in this motor register, with the help of a motor register, I need to be set to the bit of ninth, motor 9, because use at 1 as connected at the ninth bit. Okay, so that's what I'm just simply come to this one. I'm just simply go to this GPIO A. In this motor register, I need to be set to this bit. For that, I already returned this address. So this is the motor one of UART1 address has been written. And now I'm going to be set to the bit. I'm just come to this. I'm going to be ninth bit I'm going to be choosing. So because of this 2-bit, simply what I'm going to be do is, first of all, I'm just simply reset the bit. Okay, what I'm going to be do, first of all, you have to be reset the bit. For that, I'm just taking 3, because since it is having a 2-bit, it is a 2-bit, it is the modar which is contain two bits of. So I'm just simply taking the value 3. 3 means the binary value is 2. Okay, so initially I'm just give 1 1. And how many times I'm going to be shift? Initially, it is presented at this location, 0. When you're going to be shift, you are going to be shift up to 18 times. So I'm going to be made the left shift up to 18 times. So both the things are going to be located at 1 1. Okay. So I'm not going to be set this bit. I'm going to be reset the bit. Simply put 1 not operator. So while you're going to be put this not operator, it is considered as in 0 0. So simply 0 going to be left shift up to 18 times. So this position has been resetted currently, because previously if you're configured, previously if you have been worked on with this any other register, it might be in setted condition. So you can reset the values. And after that, you are going to be set your exact parameter. It is 1 0. So 1 0 binary in normal decimal, you just in normal digit we call it as in 2. Okay, so 2 you're going to be left shift up to 18 times. Simply just set the value. So that's what I've been did. So 3, which is left shift up to 18 times, but I'm just simply doing the not operate. It is going to be make the ulta like 0 0. And after you just simply set the condition. That is a port of 9 is the alternative function. That is also done. Whenever you're just alternative function you're going to be using, you have to map the function. Okay, what is mean by mapping? So you're first of all you're going to be, whenever you're just using alternative function, since it is having alternative function, you are just having alternative AFRL and this one is there. Okay, so this alternative function of low register, this alternative function of the high register. If your register, okay, if your register which is having a this one, okay, so if your register which is having a uh, you can't set the 0-bit. Okay, so you can see this one, guys. So you cannot able to set 0 0 to anywhere. Okay, you just think about it. This is one of the register GBIOA, and when you're going to be 0 going to be left shift up to 8. No, it is not going to be set. 0 is not going to be set. Always this 1 or always some other data only going to be set. If you're setting 3, yes, going to be set. If you're setting 2, going to be set. But 0 makes sense. It does not make any sense because it is a reset value. Okay, so it is just considered as a reset. So 0 cannot able to set it. Okay. So the another important thing is you are going to be do the alternative function mapping. Whenever you are just using alternative function, definitely go to this alternative function mapping. You have to be check the pin number, which pin number you are actually using. Okay, so I'm just using a port A of pin 9. Okay, before that you're going to be find out the pin mapping function. So here I'm just go to the data sheet and go to this alternative function mapping, and port A of 9 in that UART 1 I'm using UART 1 and UART currently I'm using a TX1 only. So here you just find it out which alternative function it is having. It is AF07. You just simply implemented the AF07 on here. It is not providing the ninth pin. So you're going to be considering whether it is having 9 or not. So it is a low function register, no. So in this 9, yes, it is located at alternative function mapping. Because of port A of 9, you're just configuring UART 1. You are having that. Alternative function mapping of AF07. So AF07, it is there. Simply implement 0, 1, 1, 1. That's it. You're going to be implemented. In this, how we can able to implement it, you people are going to be tell the answer. Since I'm having you all the people going to be tell the answer for this, guys. I'm just giving the 2 minute 1 minute time. You people are going to be tell the answer. So what the value I'm going to be use it for the reset. Here I used the 3 and left shift for 18 times and then reset the value because it is having the 2-bit I'm going to be using. Here I'm going to be using a 4-bit. What is the exact value I can use it for to be left shift on here? You people are going to be tell the answer. I'm going to be give 1 minute time. So exactly the first answer which is given by the Sunil and second Prashant. So exactly you give the full answer, Sunil. So superb. It's exactly right. Okay. Uh yes, I'm going to be telling. The first answer is right, Prashant. Yes, right. And Varnat Gupta, what question you have been asked? So the thing is, so I'm just simply ask you that here I'm going to be reset the value. Okay. Because your mode R register, when I'm going to be considering the mode R register, the mode R register, I just reset the value. Okay. I've been reset the value of in this 2 position. First of all, I just set the value of 1, 1, and after I just simply reset because I need to be clear out the bit. I use the temporary data of 3 because it is a 2-bit. If it is 4-bit, what value you are going to be using? So exactly, we are going to be use 15. Okay, we are not going to be use 33 and all because all the value is going to be considered it is as an like single value. Okay, it is not, if it are putting 33 means it is considered as a 33 only. So it is going to be converted to the binary value. What is the binary value of 33? So it is going to be make different. Okay, so if we are putting 15, it is considered what is the binary value of 15? It is 1111. You can also mention in the hexadecimal format of 0 cross 0 cross F. So it is also right. Okay, it is also consider it as an 15th bit. So exactly superb, really giving the great congratulations, guys. Okay, and here I'm just simply putting 0F, going to be left shift up to 4 times. I'm just simply reset the value. That's it. And after that, I need to be set the bit. So for to be set the bit, I'm just checking out what the value it is having. So it is in the 0, 1, 1. What is the binary value of 0, 1, 1? So in the order only they have been given 0, 1, 2, 3, 1. So 0, 1, 1 is 7. Okay. So I'm just simply put 7 in my value and 7 going to be left shift up to 4 times. Now I'm just simply clearing out if any bit has been previously low in set condition. I'm just clearing out and then setting my bit. Okay, so that has been completed. And now after this procedure, because this procedure is commonly going to be happen in every project you're going to be doing, because in STM32, first of all, you're going to be set to the clock. Clock is very important. And after you're going to be set to the motor register to be what functionality is going to be. After that only you're going to be read it clearly for each and every step and do it by yourself. Okay, now you just completely come to the UART one. Okay, UART, and here you can able to see the UART register. You are going to be start to study from the scratch itself. Okay, so they have been given the what is the function? It is a full duplex asynchronous communication. Okay, and it is having in the NSR standard format. So these and all the specifications. So what are the errors you might be getting? So if you people are preparing for any interviews, any things, these are the questions you might be expecting. So you just read it clearly. So they might be asking what are the errors, error detection flags. Okay, and what are the like what are the error might be happens in UART communication while you're going to be transferring that. And these are the questions you might be expecting. So you can read it clearly. Okay, and you just scroll down, scroll down, scroll down. You can have the procedure. We can have the procedure for the transmitting the bit. Okay, here they have been mentioned the transmitter. So transmitter, character transmission. So if you want to be transmitting any characters, and what is the actual procedure? So they have been given here. This is the procedure. And if you want to get the reception, I mean receiving any data, receiver for receiver. So they have been given the specific procedure. This is the procedure for receiver. So we are implementing, we are currently working transmitter. While you're going to be receiving the data, this procedure you're going to be follow up. Okay. So now we just come to this transmitter procedure. In this transmitter procedure, first of all, they have been given the enable the UART by writing the UE bit of UART1, I mean CR1 of register. And again, I'm going to be tell you guys, they won't give the structure of the programming a skill. We have to be read it again and again. We have to be like enhancing the skill, like whatever the things which is going to be set it at one time, you just write out of the loop, just configuration site. Okay, so here you just see this one. Here I've been used this UETE bit and what it and all. It is in the out of the single. It just written in this out of the single functionality. Okay, it is going to be whenever it is called, it is going to be set the bit, and whenever the things it is continuously going to be happen, the start the condition, because it is again and again going to be happen. Okay, so so it is going to be whenever whenever the transmission has been completed, if it is called, if you want to be transmit the data, it is going to be called, it is going to be happens again and again. So it is also going to be happens again and again. Okay, so based on that you are going to be configure the thing. So here, first of all, I need to be set to the bit called as an UE bit, which is located at the CR1 register. So I'm just go to this not GPIO, it is, I'm just go to this UART1. In this UART register, CR1, in the CR1, what it is actually telling, you have to be enable the UE bit. So this UE bit, you are going to be enabled, simply enable the UE bit. Okay, I'm just go to this UE bit. Here it's just telling when this bit, yeah. So when this bit is cleared, user prescaler and output are stopped and end of the current. By transfer, in order to reduce the power consumption, the bit is set and clear. So the main thing is it is going to be enabled. So this is the complete user. I already yesterday we saw like ADC enabled. ADC one going to be enabled. You have to be enabled to add on. Yesterday we know that you can able to easily relate this one in the CR1. Not exactly CR1, you have been used the CR2, right? So in the CR2, we have to enable the add-on bit. So what this add-on bit is telling? So this add-on bit is everything. So if you want to be ADC on and off, you have to be enable this complete your module. So inside this ADC, if you're on and off, it is going to be happened completely by this register only. And the same thing, it is having the complete controllability. The CR2, it is having a complete controllability. Same thing, this in this UART, the controllability which is having the CR1. So CR1, if you want to be enable the complete UART, you have to be enabled this one. Okay, that is the first procedure they have been given. And we have been did this one. So here, if I'm just not telling this address going to be right, because same thing, guys, if you are going to be use, for example, if you are going to be use UART1, right? In this UART1, you are going to be use CR1 and UE bit. UE bit is going to be enabled. If you're going to be enable or disable any bit, previously you're going to be write the address. It is very, very important thing. Okay, write the address is very, very. So same procedure. Okay, it is copy, 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 copy. Change the address. I mean pointer name, which has been given the exact name, because you can easily recognizing which address belongs to this. Okay, and what the address they have been given, you just copy it and paste it here. Here I've been using CR1 of register. Okay. If I'm not telling to write the address, you should write the address. Okay. Yes. Here I just simply enable the 13th pin. And also you have been enable the TE pin, which is in this OR operator. I'm going to be tell it. And this is the first procedure has been completed. And second procedure, program the M bit CR1 to define the word length. If you are going to be define the word length, if you are going to be telling like this is the word length, I need to be send it. You have to be enable the M bit which is present in the CR1 register. Here I'm not going to be set. If you want to be, you have to be use this M bit. Okay, it is actually telling that this bit determines the word length. Whenever you have specified the data, you're going to be sent. This is the exact data. I need to send eight data bits. I need to send the 9 data bit. If you want to specify it like that, they are going to be use this but if you don't want to specify that, you simply leave this one. Okay, and then program the number of stop bits in CR2. So mostly in usually if you're not going to be setting on anything else, it's just simply taking one bit, because we studied that the ideal condition is one. If you're setting or is it is going to be ideal. When you're going to be stop the communication, it is going to be stop. So you're going to be not implemented. And if you're going to be doing a DMA, direct register, I mean direct memory access, like the processor is not going to be involved, it just transmitting the data over memory to memory. So in this condition, you don't consider abouting this processor and all. You just memory to memory transfer going to be happens. In this time, you're going to be enabled. Here, we are not implementing DMAs and all. Okay, it is a separate concept. Okay. It is also not going to be required. And the third thing is baud rate. Baud rate is very, very important. We are already studied. So you have to select the desired baud rate using a BRR register. So you have to go to the BRR register. You just simply go to the BRR register. So in this BRR register, here they have been telling like the stop counting if TE or RE bit is disabled. So you're going to be see this. They have been simply given the two types. One is a division mandisa and another one is a fraction type. Okay, they didn't give any bit to be set. Exactly, they didn't give any bit to be set. Okay, so they just given like mandisa of UART divide. So these are 12-bit define the mandisa of UART divider. And here the fractional method, if you're going to be using that, so when the overrun is equals to 1, you are going to be, so if it here this complete data has been given on the, so give me a minute. So in this clock, they have been given the data. So you're going to be read every single things on this reference manual, guys. So then only we will get an idea. Okay. So we have to be take the values of clock because we need to be find it out the value of clock value because this is not exactly the baud rate only. It is UART. You have to be calculate the clock plus baud rate. Okay, for that motto, yes, here they have been given the specific thing like fractional baud rate generation. The baud rate of transmitter and receiver both are set same value programmed in the Mantisa are fractional value. Okay, so here, here you can able to see this one. First of all, in this normal thing, so when you're overrun, so over 8 is equals to 0. Okay, so it is considered as you are having a two types of thing. So overrun 8 is equals to 0 and overrun 8 is equals to 1. So based on the application, so whenever you're just using SPIs and all, you just go to this and a normal application. So smart card lin or any Bluetooth applications and all, you just go to this one. So here we just go to this formula. Okay, this formula we are going to be implemented that. So the normal application, normal transmitting and receiving application, we just use this formula. Okay, so here they just asking baud rate, clock frequency 16 into UART division. We have to be find it out the UART division, right? Because in this also they have been mentioned. I'm duplicating only, guys. Okay. In this use a baud rate, in this baud rate, if you just study this, they're just asking for the user division. Okay. Whether it is in the Mandisa format or fractional format. Okay. We are just find it out the value of user division. Okay. Because we can get the baud rate value. I can only set the baud rate value. You can set 9,600 because if you just search it, there is a constant baud rates are present in 9,600, 1 lakh, 5,200, 200, 1 lakh 50,200, and 4,800, and 37,000, and 57,000 values and all presented. We are going to be used 9,600, simply implemented 9,600. So you are going to be take the clock frequency. What clock frequency you are going to be used while we are studied the data sheet? We have been studied, it is having an internal clock frequency, it is going to be using 16 megahertz. Okay, and RTC purpose, it is going to be using a 32 kilohertz, and external clock it is providing this value. So most probably it is going to be using other application 16 megahertz. So I'm just simply providing a 16 megahertz for this. Okay, and formula, this is the formula of 16 into, I'm just changing the position. Okay, so changing the position like 9,600. So I'm just using my calculator. Okay, 16,000, 1, 2, 3, 4, 5, 6. You're going to be divided with 16 into 9,000. You get the value of 104.6166. You have to be converted as an x decimal value. Okay, so we have to be converted as an x decimal value because everything is going to be yes, Sonal, exactly. That is the value. So x2, we will decimal value we will convert it. For example, okay. So in decimal value, just given this one. Sorry, we have to convert it into the hexadecimal format. Okay. Okay, so I already have this value, guys. So you can also do it by, okay. So I'm just simply getting off 68 point, yes, exactly. 68.3. Okay. So the value, so it just going to be added, you just rounding off the value because A means it is 10. So just rounding off the value of 683. Okay. The thing is, I'm just simply implemented here of in baud rate, so 0 cross 683. Okay, because it is understanding a x decimal value because we have been given the pointer structure, right? So I can give this address values and all in this. So I just configured the x decimal format. It is also be done. Okay, and then next procedure, what you are going to be do, guys? I need to be set to the TE bit in the, it is TE bit. Okay, I need to be set to the TE bit which is present in the CR1. Okay, so that's what both the register. Okay, I'm going to be set to the CR1 register in this ideal frame structure. So that's what both are presented in the CR1 register. Okay, so it is presented. I need to be set this bit as 1. I need to be set this bit as U1. Okay, both need to be 1. So when you both has been get 1, so it has been start the communication. Okay, that's what it is telling. So that's what we have been done. Like, so set the 13th bit, set the third bit, enabling the UE and TE. Okay, so because it is going to be complete the set condition. And after set the condition, it has also been done. You have to write the data to the send and DR register. So it is common. Okay. In ADC also the same procedure we have been studied, right? So after you have been completed this thing, you have to be store the data. Okay. Because if you are going to be read or write the data only by this DR register, if anything going to be read the data, yesterday we are read the analog data, analog to digital data from DR register and store in one value sort of the variable. Through that we are going to be send the Arduino. Okay, that's what we are going to be doing. Today we are going to be store the data. For I'm going to be use the DR register. This clear the TXE bit and repeats the task. What is actually telling that? Because through that DR register you're going to be transmitting the data. This time your TE bit is going to be clear. Information has been cleared very clearly. Okay, TXE bit is going to be clear. Where the TXE bit is presented, it is in the status register. Because all the conditions and all which is present comes under the status. Status means what is the status? If any process which is currently happening, whether the process is currently in progress or in halt, whether it is the person are doing, so need to be find it out. The microcontroller functionality is going to be detected by SR register mostly. Okay, here the TXE bit is there. So when the data has been sent and when the buffer is free or not going to be checked. By checking that condition going to be transmit the data. So here you can able to see that. Here I just use the SR register. What this condition actually telling us, you just take the SR register. Okay, I will get the data like. If you are mentioning only the SR register, it is considering all the register which is present over there. So if you just see this, here I'm just having SR register. I'm just using I already declared the address of this SR register. Okay, SR register address has been declared. So now if I'm going to be use this, I can able to totally manipulate my SR register. I can use all the register. Currently, it is in the zero condition, right? All registers are in zero the condition, and I'm going to be mask and with seventh bit. So only the seventh bit only going to be get on. Other bits are getting zero. Now I'm going to be check this condition. I'm just continuously and with this. If we're going to be and with this, give zero. Okay. When this become one, when that register, the specific location of that TXE bit register becomes one. So it is also when you're going to be masking with this one, when it is completely give the one, your data going to be transmitted through this DR register. Okay. So it is going to be transmitted. And what about this value going to be left shifted? What we are going to be doing here it is, we just simply, uh, 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 I'm going to be clear this one. Okay. 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 Here, the value going to be right shifted up to 8. because it is having a 16-bit data. Okay, we are going to be using a 16-bit data. You will get some 8-bit of data. Simply you are going to be do the right shift operation. So while you're going to be do the right shift, you will automatically, the bits is going to be add on here. Okay, so your bits is going to be add on in this right side. Okay, your best team. So thank you, Ash. So thank you for this command for you. So thank you. So here the value going to be left shifted. So because if whenever you want the 16-bit guys, okay, yesterday we studied like I need the 12-bit ADC. I need the 12-bit ADC. What I've did, the value which I'm getting, okay, the value, one value I'm going to be get. I need the 12-bit ADC. For that, I'm just simply mask with the 12-bit, like F, F, F. Each F which is having a 4-bit. It is having a 4-bit. It is having, I will get the 12-bit. Okay, since you are using an AND operation, you don't consider about the value going to be collapsed. Okay, so here I'm just using a data register. Simply I'm going to be left right shift up to 8 times. I'm just doing with the this operation. Okay, FF means it is I'm just going to be checking the condition. Okay. And after this, it is just giving the higher bit and it is just giving the lower bit. Okay. So yesterday we add get the data through this ADC value. We have been final data has been get. Okay. Now we are going to be conclude the things. Okay. The thing is, I got one data which is stored in the location of ADC variable. Okay. Now what you are going to be do with help of UART, you have to be transmit the data to the Arduino. I'm having a data. So the data I'm just having in this ADC. The value that you are having, you just put it on the function. That is ADC. Like UART one. Okay, this function is going to be exploring use at one going to be all the bit is going to be enabled. So with help of this use at one transmit, this is the actual transmitter function is going to be do. It is checking the buffer whether it is free or not. After it is free, the data going to be transmitted in this two format. One is in the higher format, another one is a lower format. I'm going to be show it in the output. Okay, so it is helps to transmit the data. That's it. That's all about your code. Okay. And in Arduino, for to be receive the data, right? You have to be receive the Arduino data. Simply, you don't confuse it. I'm just using one baud rate setting. Here, I'm using a 9600. Here also, I'm using a 9600. Okay, in hexadecimal format. Okay, that is not issue. Here, while loop, if serial dot available is, this is the monitor, serial monitor. Currently, I'm not connected that. That's what it is open, not opening. So whenever you're giving any data, okay, if you're it is whenever the data which is coming from outside, whenever you're just giving data, it is checking whether is there any data which is available in buffer or not. That is the purpose of serial available. Serial read means when the data which is coming, it just read the data and store it, helps to store it any other variable. Here you just check it whether the data is coming or not. It should be above than 2. If it is there, you just read the data and stored in higher bit. Okay. And also stored in the another bit is going to be stored in the lower bit. Okay. So you are just checking the condition and make sure we are just doing this operation. So what you are going to be actually get at the final thing. So higher bit, it is actually giving the 16-bit. Right, because we have to be right shift and again we are going to be make sure left shift. Okay, left shift up to 8 times, you will get 8 bits and 8 bits and finally you're going to be add, you will get the value. Okay, I'm just simply connect my thing. We will debug the project. Okay, so how can I debug the thing, guys? You just simply right click, guys. So the connection, what how I made is a simple thing only. Okay, taking my Arduino and taking my STM32, connect the port meter with STM32. Okay, so here the project which you are doing is ADC over UART currently. So I'm just debug this project. So yes, once it has been done, we just simply run or giving resume button. Okay, it has been done. So currently the value, ADC value, 16-bit, because since we have been given, we are reading is that's what we have been right shift and left shift we have been made it. So 0. So I'm just simply give run. You make sure you must be upload this code because previously I just upload this code. That's what I'm just getting this data on here.